Welcome to section 2.2.1. We're going to be talking about equivalent expressions. Now, in problem 1a, we're going to be talking about designing a tile border. So here you can see the diagram. Now, there's not showing all the tiles. It's just showing some of them. So there's 4 sides with X tiles. Now, there's multiple expressions you can write for this. We can write it's 4 times each side X. But what we're doing is, because of these corner tiles, we're double counting some of them. So we'd have to subtract the 4 corner tiles. So 4X minus 4. You could also write as 4 times the quantity of X minus 1. Or 2 times the quantity of 2X minus 2. Those are all equivalent expressions. They all equal the same thing. And that's what part B is saying. You can show by distributing the 4x minus 1, you get 4x minus 4. For 2 times 2x minus 2, you get 4x minus 4. They're equivalent expressions. They're equal. Look different, but equal. So now, for this is problem actually number 2, Jill and Jarrell are looking back at their work, and they came at two different expressions. Jill had 15 minus 2x times 20 minus 2x times x, and Jarrell had 4x cubed minus 70x squared plus 300x. Are their expressions equivalent? So what we're going to do is we're going to check Jill's. 15 minus 2x, 20 minus 2x times x. I'm going to multiply the binomials first. 15 times 20 is 300. Minus 30x minus 40x plus 4x squared, and that's times x. We're going to combine first. 300 minus 70x plus 4x squared, and then we distribute the x. 300x minus 70x squared plus 4x cubed. And when we write that in standard form, 4x cubed minus 70x squared plus 300x. So you can see they're equivalent. They equal the same thing. Jeremy had another expression. So we're going to check Jeremy's. So we're going to distribute, or we're going to multiply by the 2x at the end. So multiplying the binomials, 15 times 10 is 150, minus 15x minus 20x plus 2x squared times 2x. So you get 150 minus 35x plus 2x squared. Distribute the 2x, so it gives us 300x minus 70x squared plus 4x cubed. And in standard form, we get 4x cubed minus 70x squared plus 300x. So that's equivalent as well. Now, would Jeremy and Jeremy's expression represent the same paper box? Now, if we think back to earlier in chapter 1, where we took the box and we folded it. Now, the box height for these when we cut and folded was x. Now, because of that, Jeremy's box height would be 2x, so wouldn't be equivalent. So they're not equivalent. They would have different heights. Now, there might be a case in one spot where it is equivalent, but for the most part, they would not be equivalent. So they would not be equivalent because of the different heights. Okay, next, we're going to talk about simplifying expressions. Now, we're going to, for part C, we're going to distribute. So we get 6x squared minus 15x. Multiply the binomials, we get 6x squared minus 18x plus 8x minus 24, which gives us 6x squared minus 10x minus 24. I'm going to come back to E, G, and H in a moment. So for F, a binomial times a trinomial, I'm going to distribute the 2x and then distribute the 1. So I get 6x cubed, plus 2x squared minus 10x. When I distribute the 1, I get plus 3x squared plus x minus 5. So that gives me 6x cubed plus 5x squared minus 9x minus 5. Now, we're squaring binomials. Now, there's a pattern for squaring binomials. A plus b squared. When you do that, it's a plus b times a plus b. We're multiplying them twice. Now, that gets a little cumbersome and time-consuming. We want to work more efficiently. Whenever we square a plus b, we're always going to get a squared plus 2ab plus b squared. So, for example, for e, if we're going to use that pattern, we're going to square the first term. When you square 2x, you get 4x squared. I'm going to square the last term, the negative 5, I get plus 25. And the middle term is going to be 2 times the first term times the last term. So 2 times 2x is 4x, times negative 5 is negative 20x. And there is our equivalent expression. It's all about working smarter, not harder. Now, if you're planning on taking pre-calc next year, you need to know those patterns. For g, we're going to square the 2x plus 5 first. So square the 2x, we get 4x squared. Squaring the 5, we get 25, a positive 25. And then the middle term is 2 times 2x, which is 4x, times 5 is plus 20x. And at the end, we're still subtracting the 3. So we get 4x squared plus 20x plus 22. And then for part H, we're going to square the 3x minus 2. So square the first term, we get 9x squared. Square the negative 2, we get plus 4. And then the middle term is 2 times 3x, which is 6x, times negative 2 is negative 12x. And at the end, we have our plus 5. So we have 9x squared minus 12x plus 9 is our final answer. Okay, now, in the next problems, we're simplifying using our exponent rules. So multiplying powers with the same base, we add the exponents. So it's m. 4 plus 23 is 27. I'm going to show that, excuse me. So it's m, and it's 4 plus 23, so it's m to the 27th. For dividing powers of the same base, we subtract, so it's y, and we take the top exponent 6 minus the bottom exponent 12, so you get y to the negative 6. Negative 6, or negative exponents mean reciprocal, so it's going to become 1 over y to the positive 6. And there's our answer. For part K, we're going to cube everything first. So it's 3 cubed, x, power to a power we multiply, and 2 times 3 is 6, over 2 to the third, y, negative 3 times 3 is negative 9. So 3 to the third, 3 times 3 times 3 is 27, x to the sixth, over 2 to the third, which is 8, y to the negative 9. Now, the negative exponent we can't have. So what I do is I like to circle the factor with the negative exponent, and that's the only thing that has to move. So the 27 x to the 6 stays where it is. The 8 stays where it is on the bottom, and now the y to the negative 9th moves to the top and becomes y to the positive 9th. For L, everything's multiplied here. It's 2. R cubed times s cubed times r to the negative 7th times s to the 5th. We can get rid of the grouping symbols. Everything's being multiplied. Multiply your constants first. 2, that's all we have. Now for the r's, multiplying powers of the same base, we add. 3 plus negative 7 is negative 4. S, 3 plus 5, so we get 2. R to the negative 4th, s to the 8th. No negative exponents. The only piece of the negative exponent is the r. That's the only thing that has to move. 2 stays on top, s to the 8th stays on top, and the r to the 4th is now on the bottom. with m, everything gets squared. 2 squared, x to the 4th, and y, that's a 1 there, so it's y 1 times 2 is 2. And then x squared, y to the 6th. So it gives us 4 x to the 4th, y squared, over x squared, y to the 6th. Divide. 4 divided by 1 is 4. For the x's, x, and it's 4 minus 2. And y, it's 2 minus 6. So 4x squared y to the negative 4th. It becomes 4x squared over y to the now positive 4th. The only thing that moves is the y. Everything else stays where it is. And now, for n, any non-zero number to the 0 power is 1. That's my favorite question, because all it is 1. Let's move on to some more complicated problems on the next page, please. Here, we're going to do the same thing, we just have more things to multiply. So we multiply the constants, the x's, and the y. So we have our 4, x. Now, I'm going to write this out. It's -3 plus -5. Be very careful of your exponents. And for the y, it's 1 plus 4. In the denominator, 3 times 12 is 36, x, and it's 1 plus -2. And for the y's, 2 plus -3. So it gives us 4x to the -8th, y to the 5th, over 36, x to the -1st, y to the -1st. And now we divide. For the constants, 4 over 36 reduces to 1 over 9. And now for the x's. Dividing, we subtract. So it's -8 minus -1. Be very careful of your signs. And for y, it's 5 minus -1. So it's 1 over 9. So it's x. -8 minus -1 is -8 plus 1, which is -7. And for y, 5 minus -1 is 6. Now, the only thing we can't have is the negative exponent, and the only thing that has that is the x. It's the only thing that moves. So I don't need to write the 1. We just have y to the 6th, and on the bottom, 9x to the 7th. Same thing with p. We multiply the constants. 2 times 15 is 30. X, and it's 3 plus -5. And for the y's, it's 2 plus 7. I strongly recommend writing these out to be very careful of your signs. 5 times 8 is 40. And then it's x, it's 1 plus 7. And for the y's, 3 plus -6. So that gives us 30, x to the -2nd, y to the 9th, over 40, x to the 8th, y to the -3rd. Now we do our division. Once we get that one fraction, we do our division. 30 over 40 reduces to 3 over 4. For our x's, we subtract the exponent. So x goes on top, and it's -2 minus 8. And for the y's, it's 9 minus -3. Be very careful of your signs. 3, x to the -10th, y to the 12th, over 4. So the only thing we can't have is we're good, is the x to the -10th. So it becomes 3, y to the 12th, 4, and now the x to the -10th goes on the bottom, becomes x to the +10th. And there is our answer. Okay, now, simplifying with the square roots. Remember, we have that product property, the square root of a times b. It's the square root of a, square root of b. So what we're going to do is we're going to split them up. The square root of 9, the square root of x squared, and the square root of y squared. Now, the square root of 9 is 3. And you see how x squared? That's an even number. So it's going to be a nice perfect square. So the square root of x squared, it's just 2 divided by 2, so it's x. And for y squared, the same thing. 2 divided by 2 is 1. So 3xy. For r, we start the same way. The square root is 64, the square root of x to the fourth, and the square root of y. And that's y to the first. The square root of 64 is 8. Now, x to the fourth. 4 is divisible by 2, so we can take the square root of it. So to find that, 4 divided by 2, that's going to be x squared. Now, 1 is not divisible by 2, so we're going to leave it as the square root of y. There's our answer for r. Keep doing the same thing. Square root of 25, square root of x to the 8th, and the square root of y to the 4th. Square root of 25 is 5. 8 is divisible by 2, so we can take the square root of it. So it's x. 8 divided by 2, it's going to be x to the 4th. And for the y, 4 divided by 2 is 2. For t, square root of 16, square root of x, square root of y to the 6th. Square root of 16, so we get 4. We can't take the square root of x. We're going to leave it as the square root of x because it's x to the first. It's not divisible by 2. And for 6, it is divisible by 2. So when we do that, we get y to the third. 6 divided by 2 is 3. So I'm going to clean this up. It's going to be 4y cubed, and we're going to commonly put the square root at the end, the square root of x. Now for u, we're doing the same thing. The square root of 8, square root of x to the 4th, and the square root of y squared. Now, we can't take the square root of 8, but we can take the square root of x to the 4th, which would be x squared, and the square root of y squared would be y. Now, the square root of 8, I'm just going to do this off to the side. We can simplify it. It's the square root of 4 times the square root of 2. The square root of 4 is 2, and then we're left with square root of 2. So it's 2 square root of 2 times x squared times y. So we'd write that as 2x squared y times the square root of 2. That's what our simplified answer would look like. And then finally, for part V, square root of 64, square root of x to the 4th, square root of y to the 8th, and the square root of z. Square root of 64 is 8. X to the 4th, when we take the square root of that, we get x squared. For y to the 8th, 8 divided by 2 is 4, y to the 4th. And since it's z to the first, we're just going to put the square root of z at the end. We can't take the square root of it. There's our final answer. Those are equivalent expressions. We're going to be talking a lot about this as the year goes on, and we'll keep working with this. I will see you in the next video. Thank you.